In this video, we're going to be talking about creating names and formulas for binary covalent compounds. So what is a covalent compound? Covalent compounds are any compound made up of two or more non-metals, and occasionally the metalloids will also be included. So we're really focused on these elements right here, and these create our covalent compounds. So again, we're naming binary covalent compounds. So this means a compound consisting of two elements, so only two elements. So it could have carbon and sulfur bonding, and we could have 4 carbons and 3 sulfurs. We could have any amount of these, but just two different elements. So the first thing we need to do is identify the prefix for the first element. If there's only one, do not use the prefix mono. So here's our chart of prefixes. So if there's one atom, we would say mono, 2 atoms di, 3 atoms tri. But if our first element, there's only one of those, then we don't use any prefix. If our first element, if there's 2 of our first element, then we would say di something. So then you would write the prefix and the name of the element. And then the second step is to do the same thing for the second element, except this time you're going to change the ending to "ide." Okay, so here's our first example, P2S5. So the first thing we need to do is identify the prefix for the first element. So we have the number 2. We have 2 Ps, 2 phosphorus atoms. So we would use the prefix di, and then the element is P, so it's phosphorus. So we would write diphosphorus. And then our second element, there are 5 of those. So we would use the prefix penta, and it is S, it is sulfur. So it would be pentasulfur. But then we need to change the ending to "ide, so pentasulfide. For the next one, we have CO. So notice that for carbon, we have no subscript. That means we just have one of those atoms. However, do not use mono for the first element. So we would just say carbon. Just writing carbon means that we have 1 carbon. For our second element, we also only have one of those, but since it's the second element, we will use this prefix mono. So we would have monoxide. Carbon monoxide is CO. The next one, again, we just have 1 carbon, so we just say carbon. And then we have 2 oxygen. So we would use our prefix di and change the ending to "ide, so dioxide. And for the last example, we have 2 hydrogen atoms, so we would have dihydrogen, and then we just have 1 oxygen, so we would say monoxide. Okay, so now we're going to go the opposite direction. So what if we're given the name and we need to determine the chemical formula? So we'll identify the number that corresponds to the prefix for the first element. So if our prefix for the first element is tri, then we would write a subscript of 3. You'll write the atomic symbol, so that's that letter that stands for that atom, and then you'll write the number as the subscript. And we'll do exactly the same thing for the second element. So for example, we have diphosphorus triiodide. So our first prefix would be di, and our element is phosphorus. So we would have P2, right? Di is 2, and then we have triiodide. So notice the ending is IDE. That is not the same as the element on the periodic table. It's really iodine. But remember, when we're naming, we're changing that ending of the last one. But triiodide is really iodine, and tri is 3. So we would have 3 iodines. So our chemical formula would be P2I3. Now, nitrogen hexafluoride. Notice there's no prefix in front of nitrogen. That means we just have 1 nitrogen atom, so no subscript. And then we have hexa as our prefix. Hexa means 6. Fluoride. So again, the ending was changed, so it's really fluorine, which is F, and we have 6 of those. So NF6 is nitrogen hexafluoride. And lastly, we have pentacarbon decachloride. So penta is our prefix, and that stands for 5. And carbon, so we have C5. We have 5 carbon atoms. Deca is our prefix, and that means 10. Chloride, which is chlorine, so Cl, 10. That would be pentacarbon decachloride.